Good morning and welcome to our online seminar focused on the current landscape of carbon capture and storage in Slovenia. My name is Michał Wędołowski. I'm a technology and policy manager at Bolesta Europa. Let me just can I just ask people to mute their microphones for now when you're not speaking? That's great, thank you. Bolesta is a Brussels-based climate NGO, and we have been supporting carbon capture and storage for more than 2 decades. And we are also one of the project partners in the project that has brought us here together today. The full official name of the project is Building Momentum for the Long-Term CCS Deployment in the Central and Eastern Europe region. And we have also come up with a shorter name for it, CCS4CEE. In a nutshell, the purpose of the project is to analyze the potential of carbon capture and storage in Central and Eastern Europe and to propose strategies for its deployment in the region. So our project covers 11 countries of the region, including Slovenia. And this is the second Slovenian event organized as part of the project, as we are trying to bring together and listen to the stakeholders from each country, but also to share the first results of our work. Some of you attended the workshop on the 4th of May earlier this year, during which our expert, Dr. Marko Maver, has collected your views about the CCS potential in Slovenia, which were then used in the report that Marko is currently working on. And after this event today, Marko will finalize his work on the country report, and together with the reports from the other 11 countries covered by the project, it will be published later this year and will inform our future work in the next 2 years, as we plan to propose national and regional CCS roadmaps and to help build cooperation around CCS in the CEE region as a whole. I'd like to remind as well that the project is funded by Iceland, Liechtenstein, and Norway through the EEA and Norway Grants Fund for Regional Cooperation. And you can also find more information about the project on the project website, CCS4CEE.EU, and on our social media on LinkedIn and Twitter. Just show briefly, these are our communication tools, our platforms. In case you missed the first minute of the seminar, I'd like to inform you that the seminar is being recorded, and if we get approval from all our speakers, we will also make it available as part of our project. Now let me introduce our speakers today. We are very fortunate to have with us true experts in energy and climate policy. Our first speaker, Bolesta, is a very experienced expert, not least in CCS, having worked on the early funding support instruments for CCS at the European Commission already more than a decade ago. He then held senior positions in the Polish government and is now leading the European Commission DG Energy work on CO2 capture, use and storage. Then Dr. Marko Maver is a former state secretary at the Ministry of Environment and Spatial Planning of the Slovenian government. And prior to that, he had been involved in CCS work and industrial decarbonization projects. Marko is our associated expert and author of the report Assessing the CCS Potential in Slovenia. Then we have 3 presentations by Slovenian industry. Tomasz Vuk from a cement production company, Salonit Anhovo, Ljubo Germic, representing power and district heating company Energetika Maribor, Mitja Taschler from the Slovenian power producer TESH. And just a small comment that Mr. Germic will do his presentation in Slovenian, and then Marko Maver will summarize it for us in English. We also have a presentation by Professor Blaž Likozar from the National Institute of Chemistry. And last but not least, Julian Popov, former Minister of Environment and Water in Bulgaria, currently with the European Climate Foundation and with the Building Performance Institute Europe, is a leading thinker on energy and climate with a particular focus on Southeastern Europe. And he has kindly agreed to provide his summary of the discussions today, as well as his perspective on CCS and the climate policy in general. So, Chris, let's start with you. What does the European Commission think about the role of CCS and CCU in the European economy? You ready to go?
Ready to go. Hello, good morning, everyone. Good to see you, Julian. It's been a long time. I'll try to share my content. Do you see my presentation?
I'm seeing your screen with all our faces.
That's good. That's a good start. Now? Perfect. Good. Okay. So hello, everyone, and good morning. I'm happy to take part in this event because I think that this important technology needs to have some ambassadors in the Eastern and Central Europe. You know, I could start this presentation and go on about our efforts on CCS, on power generation that we tried to do in 2006 and 2007, and how we failed and why we failed. But I think it's a different world now, because we actually learned that CCS and power generation on coal doesn't make any sense, because coal should be rid of power sectors before we deploy CCS at scale. So rightly so, I think the focus in the European Union switched to hard to abate sectors, and this is where our modeling in the European Commission shows consistently as well that CCUS has a big potential and has a big role to play. On this slide, you see that for a number of scenarios we run, CO2 captured shows as a very significant part of the decarbonization. So up to 600 million tons of CO2 will be captured in Europe, could be captured in Europe in 2050. That's an annual rate of CO2 captured. Our modeling tells us that there could be a 50-50 split between CO2 captured and stored permanently, and CO2 captured for later use in the industry as either as feedstock or maybe to put in products for permanent storage. What is really important, and I think that shows also in the taxonomy regulation, that CCS and CCU will be very important in hard to abate sectors, in steel, in cement, in chemicals. And what is even more important, and I think this is a solution that is coming more and more to the fore, is the potential of carbon removals. So you could take the CO2 from biogenic sources, for example, from sustainable biomass, and this is something I know Bellona has been advocated for years. So hat to you guys, you were well ahead of the curve. Now I think the momentum is ripe for net carbon removals, and this will further help to get rid of carbon from hard to abate sectors and from some residual emissions as well. There is a number of things we are doing at the Commission, and this slide is a very colorful set of text, and it's a terrible slide, I know, but what I want you to remember from this is that there is a lot of things going on. There is only one element that is not changing at the moment. It's the CCS directive. This is a fundament for the development of the CCS value chain. It ensures the safe storage of CO2 and also transportation of CO2, but everything else is more or less shifting. EU ETS being the key incentive mechanism for developers of CCUS projects will change. The carbon price will go up, and it will be even more key for investors in the CCUS as an incentive mechanism. Also, trans-European energy networks, the mechanism that supports investment in CO2 pipelines, is now under revision. Now it's just the CO2 pipelines that you could support from 10E, but the revision is now underway, and maybe other chains of the CCU and CCS could be covered when the revision is done. So let's see how it develops. There are some new tools, completely new tools that will also help CCS and CCU develop. From this year, CCUS fuels are encouraged under the Renewables Energy Directive. There is sustainable economy that recognizes CCS as green investment. So it's one of the economic activities qualifying as contributing to climate change mitigation. So it's guiding the financial sector towards the sustainable taxonomy is guiding the financial sector towards only green solutions and to properly label their investments. So I'm happy that CCS is recognized as one of them, and it could be another incentive for the sectors to go into that technology. The carbon removal issue I mentioned already. The Commission we started working on a certificate system, so you should hear more about that towards the end of the year. We want to put some kind of a mechanism in place to incentivize carbon removals, to incentivize these projects, because today they are not recognized under the ETS. So we have to somehow put something in place to help these projects to develop and to gain scale. I marked Horizon Europe Innovation Fund and Connecting Europe Facility as existing, but they are constantly being fed with new money. So it's also a growing pile for CCUS projects. But by far the most interesting and the most crucial funding source for CCUS now is the New Generation EU. It's 750 billion euro of new money, and you know very well that 37% of that amount will have to be spent on climate projects, and CCS and CCU have been qualified as one of potential projects to finance. Of course, there are some challenges. There's always some challenges, because I've been part of the CCS team in 2006, so I very well know where the file was and where the file is now. We still have the fossil fuel image that CCS and CCU have. This is a an inherited problem, but as I tried to explain, the discussion now in the Commission has moved from fossil fuels and capture of CO2 from coal to the domain where you have hard to decarbonize sectors, the industry, and also negative emissions possibility. So it's a totally new field for CCS and CCU. Political acceptance is still scarce, and I think it will change because of the new targets. And we know that with 2030 greenhouse gas emissions target at the high level and also climate neutrality by 2050, some see that without CCS, meeting them will be either very, very expensive or basically impossible. Of course, it has a complicated pitch. It's really difficult to explain what the CCS and CCU is in 5 minutes. It's easier to explain windmills and PV. So this is also a problem for CCS. It's a very complicated solution to climate change crisis. What is now blocking, I think it's a new challenge, what is now blocking the development at scale of CCS is the storage, security of storage supply. So there is not enough storage for projects like cement, like steel, to think about capturing CO2, because they feel like there is nowhere they could store their CO2, and there's no business models developed. There are some in the North Sea that are being put in place. So let's hope that they develop fast, and they provide this feeling that there is the security of supply of storage is there. But still, I think the momentum is here today, and I think that with new targets for 2030 and for 2050, business environment just know that they have to move on, and we match them with money and with regulation. So if you want to keep industry in Europe, the hard to abate sectors, we need to develop CCUS at scale and very fast. And with the recovery budget being in place, I see that many countries that were skeptical before on CCS project and CCU are coming to the fore, are putting more new projects on the table. It's countries like Sweden, Denmark, or closer to you in Croatia and Greece, countries that are really proposing new and quite substantial projects. And Germany also is changing their opinion on CO2 storage. So I think that with the new target, with moving the climate neutrality by 5 years in Germany, this will further spur the deployment of CCUS. Yes, these countries, I think, are crucial to the future of CCS, because you can see that there is a change in the wind, and I think that tells you a very positive story on CCUS. And I witnessed the first collapse of the demonstration exercise, the 12 big demonstration projects we planned for Europe, and I see that this is a different setup now, and I believe that now it's real beginning for CCS and CCU. Thank you very much.
Thanks, Chris. I think your message was loud and clear. So if we want to keep industry in Europe, especially hard to abate sectors, we need CCU, CCS fast and at large scale. And I'm happy to hear that the Commission has not given up after the unfortunate debut more than a decade ago. So that's very welcome. It's good to hear that there is support for this technology, for this value chain in Brussels. So do we have any questions for Chris? All right. Well, we'll let it sink in, and I see Bruno Savtic. Please go ahead, Bruno.
Hello. I've seen on the last slide it is written no onshore storage in Croatia. What does it really mean? I am from Croatia. Did you put this as a country with possible developments, or do you have an insight there are no storage places?
No, it's the implementation of the CCS directive.
What exactly do you mean? Can you explain?
We have information that the CCS directive is implemented in Croatia in a way that you cannot store CO2 onshore, only offshore.
Is it inappropriate now to ask you who told you that, because this is clearly erroneously?
Well, I'm happy to be corrected if that's the wrong information. I'll inform also my DG Klima colleagues and also update my slides. That'll be great.
Because the Croatian report has been finalized yesterday, it clearly depicts all of the legal stipulations there, and it is possible. It is even going on.
Have you sent this to us, to the European Commission, the report you finalized yesterday?
The report is now sent to Michal today. But I mean, who has told you that we do not have laws? In fact, we have now the third generation of the law that transposed the carbon directive, the CCS directive. The third generation, it was changed for the 2 times now. So the thing is going on since 2013. And I always see from the Europe this, that in Croatia we do not have it. We do have it, but maybe somebody from our ministry is giving you different information.
Well, I cannot really comment on the...
This is Slovenian workshop. I will not talk anymore. Sorry.
No, thanks, Bruno, for the.
Sorry, bye.
Thanks for the comment. Just to give other people some context, Bruno Savtic is part of the team at the University of Zagreb, who is also our associated expert in Croatia. Just like in Slovenia, they are now writing the country report. So of course these reports will be published later this year. And yeah, Chris, maybe you can also take this up with your colleagues at the Commission, and maybe the communication between Zagreb and Brussels.
Of course I will, yes.
It is just funny. Sorry. Bye, thank you.
Thanks, Bruno. Any other questions for Chris, or comments, or corrections?
They are all welcome.
Right, okay. I don't know, Chris, if you want to stay with us a bit longer, or if not, I'm happy to forward any questions to you that can, we hear next later during the seminar. Otherwise, I'm going to ask Marko to show us.
I'm staying for this because I just want to hear what's going on in Slovenia with CCUS. So I'll be happy to take questions at any time.
Great, that's great. So let's now pass it on to Marko. Marko will present the findings, preliminary findings of his country report.
Thank you, Michal. If you can see my screen. Can you hear me well?
Yes.
Yeah. Brilliant. All right. Welcome everyone also from my end. I think some of you are, as Michal mentioned, were already present at the first initial workshop about 2 months ago. And thanks also to Chris. I think the introduction, and you've placed CCS and CCUS in the right context for Europe and for Slovenia as well. I think it was particularly when you mentioned why CCUS will take off. I think it's particularly important for heavy emission industries, which obviously contribute to a significant proportion of CO2 emissions. To keep them in Europe, I think it's one of the only ways that they will be able to decarbonize, and for European countries and for Slovenia as well to actually reach its 2050 or in 2030 goals. I think when you mentioned, as a preliminary note, when you mentioned the challenges that CCUS has faced, I 100% agree with what you said, and that's also, as I'll mention later, in particular, security of storage supply. I think that's one of the cases that's kind of needs to be a priority to be addressed to kind of move towards CCS or sort of towards the storage component as opposed to only CCU in the long term. But I also would add public awareness and understanding and acceptance to one of the challenges, as that was one of the issues mentioned during the interview process within this project. I think obviously it depends on the countries, but for example, in Slovenia, I think public acceptance will be a big issue. So we've already discussed kind of what the role of CCS in Europe is. The story is similar in Slovenia. In Slovenia, we have our heavy emission industries. We have quite a long history in metallurgy, cement production, paper, chemical production, and whatnot, and they account for a significant portion of our CO2 emissions. So one of the ways that these goals will be reached is through CCUS, and stakeholders have acknowledged that this is the case, and why CCS and CCUS has to be kept on the agenda, both from the industry perspective and the government perspective as well. One of the over the past couple of months, obviously we've seen how the EUA price has risen. I can be honest that I did not expect it to, and I'm sure many of you guys have been as well, did not expect it to rise to this level as it is today. I think in some conversations, the case for application of CCS on power generation has been made, given the amount of allowances that are in place. But like we've mentioned already, I think the case for application on CCS on industry has been kind of the story in my discussions and in general as well. For Slovenia. Within our kind of policy documentation, of course, you're aware of that all the European countries had to prepare their national energy and climate plans and the long-term strategies. Both of these documents, the National Energy and Climate Plan, of course, looking towards 2030, with an outlook for 2040, and then the long-term strategy having a goal of reaching climate neutrality by 2050. Both of these documents acknowledge that CCS has a role to play in meeting our climate targets. We have storage location, and as I'll mention in the next slide, but our legislation does not allow for CO2 storage. That's one of the barriers, and we also have public awareness and understanding. As I mentioned, I think will be a likely issue leading up to CCS or even CCU or CCUS deployment in the future. That's largely stemming from the fact that there are experiences with previous infrastructure projects and the large costs involved in previous years. However, that's, I think, as I've come to find out, and I think most of you, probably all of you, would agree, is that if right engagement with local communities is done, that's not an insurmountable barrier. And what's also one of the key features is that for CCS deployment is that more funding is needed from the government, in particular, to get things started. Because industry, as I'll come to show, is interested in deployment. However, it's key for, at least for those initial steps, that it receives some government support, both in terms of funding and then also long-term policies, security. Just to give a brief overview of how things stand in terms of storage, capture, and transportation. Research in the past, from years, I think it was 20, as part of the EU Geocapacity project, and another study later on has come to find that we do have some storage capacity, about 94 million tons of CO2 at various different locations across the country, primarily in the northeastern part. But as I mentioned, current legislation forbids underground storage of CO2, and that there isn't any indication that this would likely change in the future. And from our conversations as part of these projects, largely there's an agreement that it's highly unlikely that any CO2 storage will occur in Slovenia. However, there are possible connections to neighboring countries, as I mentioned before, Italy, Croatia, and Hungary potentially as well. And I've also mentioned that there is more interest currently expressed in CCU rather than CCS. However, the storage component is not it's not excluded at this point. It's just about getting the business models developed sooner rather than later. This is just some of the stakeholder comments. Public understanding and awareness are probably some of the largest factors impacting CO2 storage and capture as well. But as I've mentioned, it was identified as a barrier, but not an insurmountable one. So public communication and engagement, in particular from the early starts of any projects that doesn't relate to CCU or CCUS only, will be key for when things really start to take off. There is interest in CO2 storage, if, for example, if clusters would develop within Slovenia or within the region, and the economy was favorable. However, as I mentioned, CCU was primary of more of interest than the storage component. We've already mentioned unlikely that any CO2 storage will occur onshore as well. In Slovenia, we've mentioned that public opposition and the current legal framework, and in Europe as well. So when the conversations were focusing on Slovenia, there was discussion about the role of public opposition in other European countries and what is going on, the current CCS developments in the north, where focus is, of course, on permanent storage in the North Sea. Also, one of the interesting components that I've come to find out is that it was mentioned that the current legislation in Slovenia is sufficient, apart from, of course, Environment Act limiting CO2 storage. However, one of the key issues identified were certain administrative procedures being lengthy and delaying projects. As far as transport is concerned, previous studies have identified that the current pipeline infrastructure is favorable, although if ad hoc projects would develop or if clusters would develop, I think new pipeline will have to be constructed. I think one of my suggestions would have been to look at potential for reuse of existing pipeline infrastructure. This hasn't been done in the past, but I think it would be a useful research for the future. Given the locations of various point sources, so that's the power plants and heavy emission industries, which on this image are identified with the little red dots, I think truck and train transportation could be an option, also due to, of course, public opposition. And developing industrial clusters and shared infrastructure, not only in Slovenia, but in the region, I think will be key for ensuring a much faster development of CCU and CCS in the region. There's quite a lot in Slovenia. There's no one directly involved with CCS as an entire chain. However, there's quite a lot of research going on currently in terms of CO2 capture. There's a lot of participation in various European projects. There's research interest in direct air capture as well. And there are, industry representatives later on will show that there is interest and plans for developing pilot projects. But as I mentioned in the beginning, one of the key steps for Slovenia at this moment is to ensure that there is funding available for these early pilot projects. as well. And I think current legislation, of course, I've mentioned the Environment Act in Article 166 is forbidding CO2 storage. However, in Article 129, which addresses the use of funds obtained from the sale of EUA allowances, so our climate fund does allow for funding to be made available for CCS and CCUS projects. So it's a question of what the government is, whether the government is inclined to support this development of this technology or not, and if funding is made available. So this is what the current status is. I've kind of mentioned it over the previous slides. The storage locations are there, although permanent storage is unlikely to occur. There's interest both from the far and the heavy emission sectors to deploy CCS. Public awareness and understanding will be key. From my conversations with various stakeholders and my colleagues and friends as well, is that there's quite a lot of misconceptions that still remain. So I think the discussion, the key next steps will be to continue raising awareness, to kind of step outside of this, I don't want to say it's CCS or CCUS vacuum, but really start to promote this technology more in the public domain as well. And as I mentioned, legal framework is sufficient, but I think the administrative procedures and are kind of the key barrier at the moment. So this is just kind of the initial findings. Happy to answer any questions at the moment, or if we're going to have them later on in the discussion. So yeah, thank you.
Thanks, Marko. So I think that's very insightful. We can see that industry is a bit in a wait-and-see mode. We can also see there's a lot of some challenges around public perception, potentially the need for some government involvement, whether in terms of regulatory framework or funding. So yes, let's see if there are any questions to Marko at this stage. Julian, go ahead.
Thank you. Just a quick question. You mentioned industry and power generation. Did you see any possible application for power generation, and how would that work?
So I was a bit hard to hear. If I see,
I think you mentioned that CCS could be applied to industry and power generation, if I'm not mistaken. I mean, do you see in Slovenia any opportunity to CCS to be applied specifically for power generation, or you're examining the case primarily from point of view of decarbonisation of hard-to-abate industries?
Well, I'm looking at the possibilities, obviously, for power generation as well, because we have one of the presenters will speak about their plans from the Tesh power plant. It's quite a significant contributor of CO2 emissions, but also employment in the Slovenian region. Obviously, Slovenia has quite ambitious, or is trying to raise its climate goals, and for that to meet those goals, coal will have to be put out of use. And it's given the restructuring of the region itself, I think CCS could play a role in, of course, ensuring that this transition towards restructuring of the region itself could be a vehicle that this is done. The Tesh power plant, of course, its fuel source is lignite coal, and it's been in operation since, I think, if someone might correct me, since 2014-15. Its planned operation was until 2054. However, I'm looking at it both from an economic, social, and environmental perspective. The current economic situation, as stated by Tesh, for 2020 could make an economic case for application of CCS. It's a question of how quickly this technology could be made available, and obviously constructed and applied.
And do you have any evaluation of cost per ton? Because I mean, coal power plants started basically going bankrupt when price of CO2 emissions was 20 euros. I mean, how would they survive if they have to pay 50 euros per ton?
Well, the current, and I might be off in numbers, but the National Energy and Climate Plan, I believe, estimates the costs of application of, or in previous research, has estimated the cost of applying CCS on, for example, the Unit 6 of the Tesh power plant at around, I think, was 400 million euros for 90% capture. I think that includes capex only. The current price, the Tesh power plant, I think overall has about 4 million allowances per year. Given the current cost of, of allowances themselves, does make the case that such an investment could potentially make economic sense if applied in the next couple of years. So it's, obviously the technology can't be applied next week or next year because obviously there's a lot of work involved, but it could be something that could extend the life of the Tesh power plant and ensure a just transition. But it depends, of course, on a lot of factors about public awareness, engagement, government support. And I think if there is kind of a renewed momentum in that aspect, I think it could potentially be there. But as I've mentioned, a representative from Tesh will give a presentation later on, so he'll describe about the stages where they're at in terms of applying CCS or CO2 capture on their power plant.
Thank you.
Thank you. Do we have any other questions to Marko? Yes, Ramona Bencina, please go ahead.
Hello, I would like to ask do you hear me?
Yes.
I would like to ask regarding previous presentation when it was written that it is under revision that for EU ETS carbon price allowances do not need to be surrendered when CO2 is geologically stored. So is it correct that now it is obliged that allowances need to be surrendered, but in the future it won't be needed? Do you understand me? I'm sorry.
Hi. Can I?
Yeah, Chris, yeah.
So no, this is already in place. So if you have a installation storing, if you are, say, an industrial installation and your CO2 is captured and permanently stored underground, respecting the CCS directive, then you don't have to pay for allowances for your emissions because they are just captured and stored. So this is already in place.
Okay, thank you.
Chris, if I may just add one thing. From our research, it seems that at least in Croatia and possibly in Poland, if that storage is in a form of enhanced oil recovery, that is not covered. That is not, you cannot claim that to not surrender your allowances. So maybe that's an important clarification.
Yes, yeah, of course. But in case of enhanced oil recovery, that some of the CO2 comes out again, so that's the issue.
Do you have any more questions or comments? Yes, Maria Trifonova, please go ahead.
Hello, thank you very much. I have questions related to the capture ratio. So Marko said that they are testing technology with 90% capture. Is it right? Potential?
Yeah, I mean, these were the cost estimates for how much it would cost to apply CCS on the Tesh power plant at 90% capture rate. Yeah.
Okay, how is it? How this technology option is actually accepted by the European Commission, because I think in the regulation it said that technology should have 100% capture potential. And what is happening with the emissions surroundings in that case?
That's an interesting question. I don't think I would have the answer at the moment. I was just basing the information on the research and cost estimates done as part of the National Energy and Climate Plan. But if I understand your question, it's essentially what happens with that remaining 10%, or given that the Commission is I didn't understand the connection with the European Commission.
Maybe Mr. Bolesta could also intervene here.
Sure. Could you repeat the question, please?
So in the normative documents of the European Commission, it said that the technology should ensure that 100% of the emissions are captured. Is this right?
This is my understanding, but I will confirm this and come back to you. But you mean the CCS directive?
Yes, and I think yesterday I also read it in the Just Transition Regulation. I guess it was also there. So my question is, what is happening with technology options or such kind of installations which can't assure 100% capture?
Well, they will probably have problems to be regarded as green, for example, through sustainable taxonomy. We also have been applying a do no significant harm rule towards money spent under the recovery budget. So this will also infringe the do no significant harm principle. So there's a number of issues at this stage, making this kind of technology very difficult to fund under the European funds, unless it's a pilot or research project, because then you have to test everything, and of course some things could be experimented upon. But if it's a commercial project, then it will be very difficult to fund it.
Okay, then the Commission would make exception with demonstration projects, for instance, for carbon capture and utilization or storage.
It's very difficult to discuss at the
98%.
When you don't know the project, so it's really hard to tell.
Okay, thank you.
We have Vano Goshnik and then Tomasz Buk.
I am producing HSU, the 100% owner of TESH. I have a very short question for Mr. Maver. There is a draft of strategic energy plan in Slovenia that requests to close TESH until the year of 2023. So, where is the sense of placing the device for capturing CO2? Very expensive device.
So if I understood your question is, where is the economic sense if the TESH power plant is to be closed by 2033? Where is the economic sense in applying this technology?
In social sense, in the sense at all.
So what sense?
Sense at all. What is the sense to build a very expensive capture device?
Yeah.
When let's say the TESH will be closed at 2023.
2023. That's in 2 years.
Sorry,
2033. Yeah, that's
33. Yes, sorry, mistake.
Yeah, no. As I mentioned before, I think you have to look at it whether it makes sense to apply CCS on power plant or any kind of CCS project, you have to look at it from economic, social, and environmental perspective. If there is a decision made that the power plant is to be closed before in 2033, then it's highly unlikely that it would make sense to invest, let's say 400 or 500 million euros to apply this technology and for it to be used for only a couple of years. If the decision is made that it would extend the life of the power plant for several years later, then it might make more sense. But it's a wholesome analysis that needs to be made whether this technology should be applied or not. But as I mentioned before, the region needs to be restructured. It depends whether, if TESH closes before 2033, it could create quite a significant, a vacuum for people if the region is not restructured before that. So it's not a black and white question or a solution. And certainly, I just mentioned it in the context as an option for potentially extending the life of the power plant itself and ensuring a transition, of course, away from coal and restructuring the region entirely. But yeah, if a decision is made that the power plant is to close before 20 or even in 2033, it's questionable whether it makes sense to start work or to invest in such an expensive technology.
Yes, it's true.
Okay, thanks, Marko. And Tomasz Vuk.
Yeah, thank you. I just wanted to comment on the previous discussion of, let's say, 100% efficiency of carbon capturing in industries. From the options analysis of, let's say, capturing technologies for cement industry, there is no such technology that can assure 100% efficiency in capturing. So the highest, let's say, efficiencies that we see and we believe it's possible to implement up to 95%. And I think if we insist to really have 100% capturing, let's say, efficiency, we will just add to the complexity and to uncertainty for a possible investor in such a technology. So I think this, let's say, idea have to be reconsidered if we want to see these applications soon in place in industrial scale.
Yeah, we were there.
Thanks for the clarification, Tomasz. I guess that's all in terms of questions for Marko. I don't see any hands raised except for Tomasz and Vano, but I think these are old questions.
We'll have some time for discussion later in following the presentations, I think. So I'm sure there's going to be more questions that will arise.
All right. So our next speaker is actually Tomasz, I think, on behalf of Salonit.
Mm-hmm. Marko, will you share the presentation?
Actually, I'll do that. Sorry, okay. I have the presentation open.
Okay. Yeah, thank you. So my name is Tomasz Vuk. I'm coming from Salonit Anhovo, cement factory. I've been working for Salonit for more than 25 years, and most of my time I spent in technology issues, technology development of the plant. So just go to the next slide. I just want for the beginning to really put some figures so that we have an idea why, let's say, decarbonization of cement industry is important for the society. And we should know that concrete, together with cement, is the most widely used material in modern society. Worldwide, we build some 10 cubic kilometers of concrete per year, 5 times more than bricks, 10 times more than wood or timber, and 100 times more than steel. So it's really very important material. Approximately 40% of all the mass in the European buildings is built from concrete. And therefore, we also have a very big impact on the greenhouse gas emissions. And so it's really important to decarbonize this sector. Maybe also, if you look at the LCA analysis and comparing, let's say, buildings from concrete and wood, there are many different studies, but more or less at the end of the day, we see no benefits of one or the other material. But once we decarbonize cement production, then the story is really changed. Then we see a huge advantage in using concrete, which is purely local material and has many benefits. Next slide, please. So in our company, in last, let's say, 10 years, we already did a huge step in terms of reduction of CO2 emissions. And now we emit per ton of product some 10% less than average cement factory in Europe and average cement factory in Germany. And we still see the potential of further reduction of 10 to 15% in next 5 years using the, let's say, technologies that are already present in our industry. So no, let's say, new technologies. Approximately 60% of this improvement would come from fuel. So turning from fossil fuels, using more fuels that are based on biogenic carbon. And let's say 40% of this would come from recycling of building materials and using some, let's say, waste stream from other industries as a raw material for cement production. Next slide. With this, we would then, let's say, explore the traditional technologies that are present in cement industry, and then for next step towards the carbon neutrality, we need to, from our perspective right now, we need to capture the CO2 emissions. Now, from cement, 1/3 of CO2 is coming from fuels and 2/3 are coming from raw materials, basically from limestone. And therefore, we have huge volumes of this CO2. So our idea is to, let's say, between years 2025 and 2030, we would like to have a pilot to explore this, let's say, potentials of these technologies, and then to build a full industrial scale application somewhere after year 2035. Because to go in a full scale, we need to answer some important questions that were addressed already before from Marko's side. If you go ahead. We think this cannot be done as one company alone. We need partnerships. So we have two options. One is the carbon usage. In this case, we see huge energy needs to make it. I will show you later what is the magnitude of this. And if we go to the storage, we don't see our, let's say, our purpose of being to build such a storage. So we need to rely on some other projects that will provide a proper storage for this. And we think that building a pilot could contribute to, let's say, setup of such interested groups to build these, let's say, final solutions, options, and then finally to decide for some of those options and to build the final solution for decarbonization of our sector. So if we go next slide. Here is some figures connected to this carbon capturing issue in our case. So for 1 million ton of cement clinker produced, we generate some 700,000 tons of CO2. And already for capturing this, we would need twice as much as electrical power than we need right now. And then if we want to convert this to, let's say, organic compounds, we estimate that we need 4 terawatt-hours of power to convert this. And this is approximately the amount of energy that is provided from a nuclear power plant for Slovenia. So it's a really big magnitude. And of course, at the end, the aim is to generate this power from renewable energies. So we don't think with this speed that we see right now in Slovenia, that we will be soon in a position to have so much power generated from renewables just to cover the needs of this CO2 transformation to something useful. Next slide. And then we come to the importance of this carbon capture, because from this analysis, we assume that maybe we will have let's say, a period. So we will build a capturing facility in our plant, and then we will need to have an option to store this CO2, at least for a certain transition period. And then once we might have enough green power to turn it to a useful material, maybe we can then switch this to, let's say, carbon usage. And also this carbon storage is a very complex value chain. So it's first capturing already quite complex engineering task already in the plant. Then we have preparation of this CO2, then we have transportation of CO2, and then we have injection and storage and monitoring of the site. We tried to estimate the potential costs. We are talking in our case of the, let's say, magnitude of 75 to 200 euro basically. And this is already higher than is a CO2 price on in the ETS scheme. So if we want to go this way, we will need to find kind of a support for the first movers, so that we have a kind of let's say that we don't expect that individual companies will take all the risks in this transition. Next slide. These are the technologies, let's say, relevant for cement industry. I have to say that is compared to some other industries, it's a bit more. We have some advantages, so we have some higher concentration of CO2 in the gases, but on the other hand, we have more dust in the gases, so these technologies need to take into account also these challenges. And basically, we are talking about 3 clusters of technologies, so post-combustion chemical adsorption, then we have physical post-combustion technologies and integrated capturing technologies, where you need to also, let's say, change the complete process. And the most developed are chemical post-combustions, but with the drawback that the most expensive one. Big potential we see in this physical post-combustion. The drawback is maybe not so high efficiency, and they are not so well developed yet. And then these integrated technologies are the most difficult because you really need to change the complete process. And this is also connected to quite high technical risks in plants. Let's say, final conclusion from all these things is that we are talking about very complex process to be made already in the plant itself, and then also to build the all necessary environmental infrastructure where we can then finally store the CO2. Next slide, please. We also checked, let's say, from public sources, some projects that are running in our neighboring countries. We see some projects in Italy, in Croatia, and in Austria. And I think that anyhow, to really make a step forward, we will need to build this infrastructure together with our neighbors, or let's say in line, or yeah, we need to see over our borders and to really look at the industrial clusters and then to build infrastructure according to this, let's say, already given situation. Because this will give all of us much higher security and also better efficiency, also in terms of costs. Next slide. Yeah, and this is maybe one, let's say, concrete project where I don't know, I haven't checked more details, but this at least is announced that in 2030 they would be able to, let's say, accept huge volumes of CO2, and this is something that, let's say, on industrial side we would like to see. So some concrete figures in terms of time scale, because then we can design also our, let's say, roadmaps much better and with much higher security, and to really make these technologies and this transformation happen, the, let's say, the right, so the risk topics have to be covered well, and we need to have some predictable business environment to really go in a direction of this next step of making industrial sector green. Thank you.
Many thanks, Tomasz. Very informative, and good to see the ambition is there in the cement sector. I'm going to ask Energetika Maribor to present next, and we'll take the questions after all the presentations, just for the time management sake. I hope that's fine with everyone. So I'm going to share the slide. Or is Lyubo going to share his presentation? I can do that. And I think this presentation is going to be in Slovenian, and then Marko will summarize it for us in English.
Do we hear each other?
Yes.
Do you see my presentation as well?
Yes, we do.
Yeah.
Okay. Hello to everybody, and I would like to thank to be a part of this important workshop, and I would like to also thanks to Marko Maver to invite me to be a part and give a short explanation what we are doing in Energetika Maribor. And I prepared my presentation in English, but it was already mentioned. Marko will give a summary at the end. Energetika, what is my role that I play in our company? I'm a manager, director, advisor, and I'm responsible for development and research work, how to change, how to transform this our company from complete fossil fuels to heat production, and change our sources to more renewables, and at the end the main goal is how to reduce the CO2 emissions. Okay, I will proceed now in the Slovenian language, but my presentation is in English. Some short informations about our company. Torej mi proizvedemo okoli 107 MW, torej imamo inštalirane moči za proizvodnjo toplote 107 MW in proizvodnja 115 tisoč megavatnih ur na leto. toplote, elektrike pa so proizvodnji 11 MW nazivne moči in pa proizvodnje elektrike okrog 90 tisoč megavatnih ur. Letno 45 zaposlenih, imamo 40 let tradicije znanja in izkušenj proizvodnje toplote in njene distribucije in seveda z aktivnim deležem pri reševanju problemov pozitivnih vplivov na okolje. In pa seveda zelo pomemben cilj, ki ga sledimo, je tudi zmanjšanje energetske revščine. Če pogledamo proizvodnjo v energetiki Maribor, lahko ugotovimo, da imamo 8 motorjev na zemeljski plin, kjer proizvedemo čez 70% toplote letno, tako za centralno ogrevanje kot sanitarno toplo vodo, kjer oskrbljujemo čez 13 tisoč gospodinjstev in okrog slabih 400 odjemalcev tako imenovanega storitvenega sektorja. In pa seveda v teh kogeneracijskih napravah proizvedemo okrog 90 tisoč megavatnih ur elektrike. In če mogoče samo opozorimo na povečanje učinkovitosti našega sistema skladno z zakonom o učinkoviti rabi energije in skladno z direktivo o učinkoviti rabi energije, moramo poudariti, da je energetika Maribor učinkovit sistem daljinskega ogrevanja skladno z zavezami, ki jih prinašata tako direktiva kot omenjeni zakon. In pa seveda za, bom rekel, tako imenovane konice, proizvedemo okrog 33 tisoč megavatnih ur toplote na leto. Ker se zavedamo, da je eden izmed ključnih ciljev pri boju z podnebnimi spremembami zmanjšanje emisij toplogrednih plinov, smo v zadnjih 2 letih gradili na naše, bom rekel, površine streh, tako imenovane sončne sprejemnike, s čimer proizvedemo 130 megavatnih ur energije na leto, kar pomeni znižanje emisij CO2 za 17 ton letno zaradi manjše primarne rabe zemeljskega plina. In pa potem smo vgradili 5 zalogovnikov, kjer smo s pomočjo teh zalogovnikov lahko bistveno bolj optimizirali proizvodnjo in toplote v kogeneracijskih napravah in na ta način prihranili okrog 4500 ton CO2 na leto. Kakšni so naši načrti za v prihodnje? Ker je v naši proizvodnji več ali manj samo prisoten zemeljski plin, je prvi cilj, ki ga mislimo uresničiti v naslednjem letu, je visokotemperaturna toplotna črpalka, ki bi dopolnila ki bi dogrevala naše povratne tokove na način, da seveda zmanjšamo porabo primarne energije z izkoriščanjem toplote reke Drave za visokotemperaturno črpalko nazivne toplotne moči 2,4 megavate, kjer bi bil potem izplen v toploti 1600 kilovatov pri maksimalnem toku reke Drave 99 litrov na sekundo. Drugi ukrep investicij, ki jih bomo izvajali, je izvedba sončne elektrarne na naših parkirnih površinah in na naših stavbah, kjer bomo vgradili okrog 345 panele 345 vatov torej v skupni inštalirani moči 254 kilovatov. In pa ključno in tudi pomembno, vezano tudi na današnji govor, je, kako v Sloveniji ali sploh izrabiti odpadke v energetsko izrabo. Tukaj bi pa sedaj seveda šel malo globje v razpravo in seveda z željo, da bi na tej poti lahko bili udeleženi tudi na tistem delu, o katerem pravzaprav do zdaj nismo razmišljali. To pa je, kako in na kakšen način zajeti recimo te emisije toplogrednega CO2, in bi mogoče nekaj več o tem povedal. Torej, situacija, ki danes imamo v našem podjetju, je, da proizvedemo celotno energijo, toplotne energije v višini 261-500 megavatnih ur in pri tem emitiramo 45, slabih 46 tisoč ton CO2 na leto. Torej, naslednjo, kot smo že dejali, je integracija te toplotne črpalke na pristanu, to je na enem izmed naših obratov proizvodnje, in pa seveda waste to energy plant, torej energijsko izrabo odpadkov, in iz tega naslova seveda vidimo kot potencial možnost zajemanja in shranjevanja CO2. Kakšna je situacija na področju odpadkov v Sloveniji? Slovenija nima neke jasne določene vizije in tudi ni razen, bom rekel, jasno sprejete hierarhije na področju ravnanja z odpadki, od minimiziranja na izvoru, ponovne uporabe, recikliranja, termične izrabe in seveda končno tudi odlaganje, kar pa seveda ni cilj. V Sloveniji ocenjujemo, da je na razpolago med 500 do 600 tisoč ton odpadkov, ki bi jih bilo možno energijsko izrabiti, pri čemer pa opozarjamo, da je v okviru javne gospodarske službe v pristojnosti države vezana samo tista frakcija mešanih komunalnih odpadkov, ki ustreza določenemu šifrantu 19-12-12. Kje vidimo možnosti lokacij? Ena, ki že obstaja in bi bila predvidena za širitev, je Celje, nato so planirane Kočevje, Ljubljana in Maribor. Pri tem je treba poudariti tudi z vidika možnosti zajemanja CO2, da v tem trenutku še ni natančno definiran izbor tehnologije sežiga, ki bo uporabljen v teh obratih, seveda, če bodo te odločitve na državni ravni dokončno tudi prišlo. Seveda pa se zavedamo, da uporabljene tehnologije bodo morali zagotavljati izpolnjevanje največjih okoljskih in drugih družbeno sprejemljivih standardov, tako imenovanih brez določil, skladno z najboljšo razpoložljivo tehnologijo. Tukaj opozarjamo pač, da gre za 4 lokacije in 4 lokacije potencialno lahko predstavljajo potencial za zajemanje CO2. Torej, kot sem že dejal, gre za mešane komunalne odpadke v Sloveniji. V Mariboru bi tega bilo približno 45 tisoč ton in zaledje je celotno severovzhodna Slovenija. V okviru tega mariborskega projekta bi imeli nazivno moč te naprave okrog 20 megavatov toplote in 4 megavate elektrike. Naprava se pričakuje, da bo delovala več kot maksimalno, torej dobrih 8000 ur na leto in proizvodnja 81 tisoč megavatnih ur toplote in 35 tisoč megavatnih ur elektrike. Torej, ob tej proizvodnji toplote in elektrike se pričakuje 16 tisoč ton emisij CO2-ja na leto. Pri tem je treba pač opozoriti na dejstvo, glede na to, da bi Maribor predstavljal samo eno lokacijo za sežig, da je to le približno 1/4 odpadkov, ki bi jih v okviru javne gospodarske službe države sežigali v Mariboru, kar pomeni, da celokupna emisija bi bila iz teh naprav v Sloveniji štirikrat večja, kar pomeni, da bi imeli celokupne emisije okrog 70 do 80 tisoč ton CO2 na leto. In tukaj na koncu samo še informativno, kjer smo prikazali leto 2020, v krogu desno zgoraj je naša struktura proizvodnje 65% kogeneracij v oranžnem delu kroga in 35 iz kotlov vse na zemeljski plin. Z vgradnjo toplotne črpalke, ki bi povečali delež obnovljivih virov energije, kar je prikazano zeleno v letu 2025 in leto 2030, ko izgradimo to sežigalnico, pravzaprav vidite, kako ozelenimo z vidika proizvodnje našo proizvodnjo toplote. Seveda pa to še ne pomeni, da ko bomo zamenjali zemeljski plin z proizvodnjo toplote z termično predelavo, da na ta način bomo tudi ustrezno zmanjšali tudi emisije CO2. In samo še mreža, rdečo, kar je na zemljevidu z rdečo barvo, te veje pomenijo današnjo situacijo, vijoličasto situacijo 2025 in dodano še potem na desnem bregu reke Dave je tudi situacija v letu 2030. Tako da v energetiki Maribor se zelo zavedamo, da bo potrebno transformirati naš sistem proizvodnje toplote, tako z vidika uvajanja obnovljivih virov energije, kot z vidika zmanjševanja emisij CO2. Sistem mora ohranjati svojo učinkovitost tudi z ukrepi za zmanjšanje izgub. In če mi na koncu seveda dovolite, glede na to, da sem tudi predsednik sekcije za daljinsko ogrevanje pri Energetski zbornici Slovenije, vsi, torej največji sistemi se zavedamo potrebe po tej in nujnosti te transformacije in zato je seveda za nas zelo pomemben tudi pravni okvir, v katerem se nahajamo, tako strateški dokument, nacionalni energetsko-podnebni načrt, v katerem seveda jasno piše, da na področju toplote pričakujemo jasno strategijo, ki je v toku priprave in seveda akcijski načrt za sisteme daljinskega ogrevanja, ki seveda smo prepričani in tudi pripravljeni pomembno prispevati k razogljičenju v Republiki Sloveniji v okviru energetskega sektorja, kajti sistemi daljinskega sektorja v končni rabi energije predstavljajo približno 5% delež. In glede na evropske smernice in usmeritve postajajo na območjih goste poselitve ti sistemi prioritetni način ogrevanja, smo prepričani, da naši sistemi lahko odgovorijo na izzive in seveda današnja delavnica bo tudi za nas v okviru sekcije pomenila izjemno pomembno sporočilo, kajti razmisleka o tem, da bi se ukvarjali tudi z projekti torej zajemanja in shranjevanja CO2, bom rekel, pri nas do zdaj ni bila bistveno pomembno področje razmisleka. Tako da hvala še enkrat za priložnost za današnjo prezentacijo in seveda želim tej skupini v okviru tega projekta in tudi za Slovenijo uspešno iskanje rešitev. Mi pa seveda za to prezentacijo iščemo partnerje, kako odgovoriti na to vprašanje zmanjšanja emisij oziroma lovljenje toplogrednega plina CO2 pri recimo novih projektih termične predelave odpadkov. Hvala lepa.
Hvala.
Thank you.
Thank you very much.
Marko, do you wanna?
Sure. Yeah, I think because for the sake of time, I'll just give a brief summary. Obviously, the presentation was done in English, so the presentations will be provided for the participants. But essentially, what Mr. Gerimic has mentioned, that Energetika Maribor, obviously after presenting what they do, and one of their most important goals for the company is to reduce their climate impact and also reduce energy poverty. So they are aware of the importance of climate change and how to fight it. So they've invested a lot in building solar panels on their facilities, which reduce their emissions for 70% per year. But they're also looking for, they've built heat storage tanks, but key in the context of our workshop today is that they're looking for plants in the future. One of their goals is to also construct a waste incinerator. Obviously, that will depend on the government's support and also the strategy that will be in place. Mr. Gerimic identified 4 possible locations in Slovenia that the waste incinerators could be constructed. They're looking at one in Maribor, and they're looking for essentially for partners in this story. So they're looking what the situation will develop in other parts of the country and in the region, and how they can work with not only Slovenian but also foreign partners in helping them implement the CO2 capture technology once the waste incinerator is constructed. He mentioned that 2030 would be the goal for that. And because the company itself is interested in reducing their climate impact even further in the future. So that's just kind of the main aspects of it.
Thank you, Marko, for the summary. Let's move on to, I think the next speaker is from Tesh.
Yes.
Great.
Okay, hello everybody. I will just make a short introduction. My name is Mitja Taschler, Director of Power Plant Šaštan. Like you know, we are the biggest emitter of CO2 in Slovenia. And this is not something new for us. We have the longest history in the CCS development. Mr. Vane Gošnik will take later the word, and he will explain what we did already in the past, because we are working on this already for 15 or more years, not from yesterday. And also what are our findings, our conclusions, and what is our main goal for the future. So if we will have any questions on the end, for sure we are both available with Mr. Vane Gošnik. But now I will pass the word to him, that he will explain all what we already do in the past and what are our plans for the future. So Vane, please. Zvočnik.
Okay. Is it Lishmo? Okay. Good day to all participants. My name is Vane Gošnik, and I'm involved in CCS projects in HSE Group since 2006. I will be very brief, but in the introduction, I'd like to present you some undisputed facts. The people who claim that CO2 is pollution and poison gas are completely wrong. Without CO2, there is no life on the Earth. Plants are producing oxygen using CO2 and sun energy. That is simple truth. What they teach in primary schools. Without plants, there is no food for people and animals, and there is no oxygen for breathing. As simple as that. Radical reduction of CO2 in Earth's atmosphere means that mankind will disappear. That's why oxygen and CO2 are our vital condition for our survival. Nevertheless, there are Kyoto Protocol, Climate Agreement, Paris Agreement, European directives and obligations which Slovenia must respect and implement. Agency tackled this problem as early as 2008. That's when we started so-called ZTPO project. I will show you. Can you see it? Can you see the slide? You see the slide?
Yes.
Yes. These are participants, organization of project. So these are results of this project. Then we started, as I said, ZTPO project. As you can see, the project founded 5 participants and was also supported by the Slovenian government. The project was carried out by 5 Slovenian research institutions. The results were mainly 2. First, we became acquainted with state-of-the-art CO2 capture technologies, including IGGC technology. And second, we found out whether there are capacities for permanent CO2 storage in Slovenia and its surroundings. The answer to the first question is pretty clear. There are some primary post-combustion projects in Europe and worldwide, but just a very few is commercial wide scale. For example, coal power plant Petronova in USA near the Canadian border, 240 megawatt, capturing, for example, 1.5 million tons of CO2 per year, dash approximately 5 million per year. It is cost effective, sorry for that reason that CO2 sells to an oil company in IOR project. The answer to second pipeline. The answer to second question is unambiguous. There is no such a place in Slovenia and in a wider area. There are not such locations. The only potential option is in Petišovci, in northeast part of Slovenia, in an exhausted gas field. But the full capacity of the potential warehouse is only 5 million tons, which would be enough for a year and a half of TESH production of CO2. The other option is, unfortunately, to transport CO2 to the North Sea, which is associated with exceptional transport and storage costs. However, this would be affordable only with an exceptional increase in emission coupon prices, probably over 200 euros per ton. Shortly, Slovenia do not have possibilities for onshore permanent storage, which by Slovenian law is also impossible. Therefore, HSE is currently focusing on CCU projects, which means seeking opportunities for the commercial use of the captured CO2. For example, our proposal is to set up a pilot post-combustion device for capturing CO2 with capacity approximately 5 tons per day, and its use for commercial purposes such as food industry or producing synthetic gas. And for the end, there is a draft of strategic, as I said before, strategic energy plan that requests to close TESH until the year 2032. So where is the point of placing an expensive device for capturing of CO2? That is a very, very, very important question. Thanks for now.
Thank you for this. Let's move on now to the presentation of the National Institute of Chemistry, and we have Professor Blaž Likozar. You ready with your presentation?
Yeah, I will share it myself. Okay.
That's great. Thank you.
Do you see it?
Yes.
Okay. So I will briefly present you the activities that we have in the realm of let's say, CCU as well as the upstream decarbonization, mostly within the frameworks of international pilot and demo projects, which I think should be the ones to be to some extent also implemented here, because they are key to understanding and gaining the engineering know-how to basically be prepared for the energy transition and decarbonization. So I'm coming from the National Institute of Chemistry. Basically, the institute is located in Ljubljana. We are a chemical engineering department, and hence also our role in various parts of either CCU, carbon capture, power to gas, power to liquid, but also upstream hydrogen introduction and storage in process in energy intensive industry. So I think that all in all, the decarbonization and energy transition is leaning on 3 pillars if you exclude the renewable energy sources to begin with. So one is battery systems, which are quite advanced within the institute, but I won't be talking about those today. I will rather focus on CO2 technologies and hydrogen technology, which I think is also crucial to look at upstream decarbonization to basically, in some instances even prevent a need for carbon capture, storage and utilization to be implemented. So what's important is to look also at methane, not only CO2, as an important greenhouse gas. So let's say the valorization of methane is, I think, one of the key pillars of an efficient GHG emission, especially when looking at, let's say, point exhaust sources. And this was one of the pillars of the project DREAM when we were looking at, let's say, pretty high TRL, so about 6 deployment of electrified natural gas conversion processes. So in this case also we are, let's say, basically decreasing the emissions on their source, either methane by itself or methane being converted to CO2 because it's flared. Within the Slovenian context, this is mostly relevant for biogas, which is also gaining traction here. One additional thing that's maybe less considered or discussed in addition to CO2 is, of course, CO as the energy carrier. So if you look at the world map there, you see a large CO2 emission cloud over China. And why is this important? Because CO in general is a energy potent molecule. So with it you can produce CO2 to be captured, but on the other hand also hydrogen is an energy carrier vector. CO, methanol and ethanol also play a major role within the let's say cycling and CCU when considering pathways of CO2 valorization. So basically methanol and ethanol are, besides DME, are perhaps the most prominent hydrogen vectors combined with the nexus of CO2 capture. So here in the picture you can see an example of pretty high TRL 6 to 7 demo unit for the water gas shift unit to produce hydrogen placed in Sweden. One thing perhaps not so relevant for Slovenia, but I guess a bit more for our neighbors in Croatia, would be ammonia. So we've just started a large-scale ammonia project with coordinated by Danish counterparts. Ammonia is interested because in general it's let's say carbonless hydrogen carrier, and within the project called Oracle we're developing decentralized production and decomposition back to produce and bind hydrogen. Nonetheless, ammonia is also very interesting in terms of fertilizers production, and this is also where the CCU comes into play. You can see when producing let's say urea as a building block for either resins or for the fertilizers, you are combining to some extent renewable hydrogen utilization as well as CO2. One other thing that we started basically in 2014 already was MEF CO2 project, in which we were one of the main partners for the CCU, so power to liquid methanol synthesis. And this was actually the pilot or demo unit was actually placed in one of the biggest, I think it's the second biggest power plant in Germany, operated by RWE in Niederhausen near Köln. Not just the energy industry, as mentioned before, also steel industry decarbonization is very important, considering the nexus with CCU. So, of course, in the long-term perspective, the transition will be to hydrogen use for the reduction of ore. But nonetheless, anybody dealing with iron and steel industry knows that carbon needs to be there. Carbon is an essential part of the steel itself, the alloy. So basically, in essence, you won't be able to avoid CO2 completely. But in this case, it was also, let's say, a large-scale demo case of industrial symbiosis, where we were also involved in the CCU part, so the methanol conversion. The industrial symbiosis discussed is basically the nexus between steel industry and chemical industry producing methanol. So SPIRE was an umbrella organization that was looking at the decarbonization of energy intensive industry, what we are discussing today. It's been succeeded by the Processes for Planet initiative. That's basically starting already the first calls in September this year within Horizon Europe. But of course, in the long-term perspective, you can see a nice illustration on the upper left-hand side. There will be a mix of solutions, either from hydrogen, CCU, but also biomass to provide the hard-to-decarbonize sectors like, for example, ammonia in shipping, e-fuels for aviation, hydrogen for industry decarbonization, probably also hydrogen for long-haul mobility, but batteries for, let's say, urban mobility. But just as an illustration that, the future won't be just about one solution, but a mix thereof. Something that we are particularly good at ourselves is the, let's say, multi-scalar approach, basically going from the actual catalysis, which is essential to the energy transition and CCU. But then again, also, let's say, to plant level techno-economics, basically integrating different mature technologies and looking how they operate under the conditions of intermittent and transient renewables. So what I think is crucial that is missing in Slovenia, as opposed to the, let's say, various pilot and demo valleys or sites abroad, is that there's a serious lack of pilot or demo cases here. Of course, as was mentioned in many of the previous presentations, everybody's looking for break-even, and there's just not a business case there already considering hydrogen or CCU, but also anybody carefully tracking the price of CO2 coupons is well aware that it's something that should be considered very, very seriously. And I think implementing pilots and demos is something that is paramount in a way that it's not a commercial technology that is deployed directly, but it's something that aids a company to gain know-how, expertise, engineering, and competitive advantage in this regard, so that there is a smooth or continuous or sustainable transition towards the actual commercialization in 10 to 20 years time. Whoever will not be implementing such an approach might lose the competitive advantage. So on the upstream, of course, it's the hydrogen or direct electricity use in heating. On the downstream, it's power to gas, power to liquid, or power to polymers. As mentioned before, in the future, there won't be one-size-fits-all approach. traditional unit operation is steady, emerging unit operation will be smaller, dynamic, flexible, and buffering the intermittent renewables. Traditional feedstocks are essentially constant, so natural gas, oil, but emerging feedstock resources are varying, diluted, and contain impurities. So that's the key innovations also at higher TRL. Digital twinning is imperative. Not doing so, one loses a lot of revenue in this regard. I think we've heard from some of the largest emitters today, and yeah, I think that looking at what's happening broader in Europe, of course, CCU is not something to be implemented commercially today, but it's probably something that one will not be able to go without in the 10 to 20 years perspective, perhaps even sooner. So the whole COVID situation has shown that the decarbonization might be ushered in much faster than everybody was approaching. So I would just maybe like to conclude with very good cooperation that we have, and I think it's one of the most impressive, let's say, upstream decarbonization cases in Slovenia, which we are particularly proud of because we were on the side of the initiators of the project with Steklarna Hrastnik, where actually a part of the natural gas and oxy-fuel combustion on a pilot to demo scale is being replaced by hydrogen from electrolyzer. What makes this business case so appealing is that a part of the product of electrolysis, oxygen, can in perspective be basically fed to the oxy-fuel combustion. But of course, there's a lot of challenges as well, because the quality of product glass depends on the temperature distribution of flame, which is changing over time because you are feeding hydrogen based on the electricity prices. You get a part of the revenue also from the long-term contract with the electricity distributor, but all of these key components were a part of the project, and so were we. And yeah, basically this is something that we want to put forward as a take-home message, that we're very interested to replicate our successful cooperation with Steklarna, with other cases presented today, where we are aware that this is not basic research, and I think that we can contribute to this if there would be any interest for that. Thank you.
Thanks a lot, Blaž, for this presentation. It's good to have the voice of the research community as well. Now let's ask Julian, what do you make out of these discussions? What's your view on that?
Thank you, Michal. Thank you very much. It was exceptionally interesting and rich discussion, presenting many different views, hopes, desires, and also barriers and issues. I will start with just a brief summary or even just listing few key points that I kind of registered, and then I will share my view. All that will be quite subjective, so if somebody doesn't hear the right thing, that's entirely my fault. I think I would start with the first sentence of what Krzysztof said, that the carbon capture and storage and CCU also are very much focused on the hard to abate sectors, and the attempts to save coal power generation and had not proved successful so far. I mean, I remember the European Commission, we spent a lot of money and billions even on trying and testing that, but also that was in a different environment when renewable energy was also very expensive, and so technology was different. Specifically for Slovenia, it's the case is very interesting because obviously there is a problem with storage, problem with public acceptance, problem with regulation. And what I hear is that there is a need for international cooperation. This is something that we hear a lot, that it is very difficult to develop a CCS case just separately and individually, and we have to think in a more like cement and steel industry and chemical industry and all these industries that we don't have the solutions for them now for their full decarbonization. And that would be very important to focus the research on them. It was very interesting to hear the presentation of Thomas Vuk, because that's where we heard more about the costs. I mean, it is known that the CCS cost is very difficult to determine because there is no real market. Most of the research either has failed or is in kind of initial or middle term, and it's in most cases it is very much subsidized and supported, except probably cases of enhanced oil recovery where the business case is a bit more obvious, but still that brings other issues and difficulties, including that we need to find oil in order to recover it. So it's a completely different story. And and the final presentation that we heard was also very interesting because it pointed towards the need to develop further the research and put a lot of effort, a lot of resources, research, and in order to enlarge our view and to understand where the technology is going. Because, and here I will move more to my kind of personal take, is that the whole area of CCS is still in the direction of testing, of understanding and finding the right regulatory and scientific dimensions of it. So, and for that we need cooperation, and we need cooperation in research, we need cooperation in pilot projects, we need cooperation in regulatory and legislative direction. One thing about which I think we should always be very careful when we talk about CCS and especially CCU. CCU should be CCS. I mean, carbon capture and utilization should not be something that utilizes carbon at one point in order to burn it in another point. Because so we have to look into the carbon intensity or the utilization and storage potential of the whole process. So in that sense, I have a very kind of strong question about if we capture carbon and then turn it into methane and then burn it somewhere else, is that something that makes sense? Because the fact that you don't release the carbon in one place but release it in some other place is not certainly not a solution. So the carbon should end up somewhere captured, even when we talk about utilization. So, And one thing that we haven't discussed, and it's always been a problem, is the volumes when it comes to carbon capture and utilization. I mean, carbon capture and utilization is a developed market around the world. It's developed technology. It is used in many things, but it is limited. And is there such thing as massive expansion of carbon utilization that could make large volumes of carbon channeled into products that can capture that that carbon through utilizing it? Because as I said, I mean, utilization should be capturing as well. And I mean, the very common and an ancient way of carbon capture and utilization is using wood for buildings, for instance, or anything else. And of course, the whole debate, in my view, focuses very much on cost, and seeing that the cost of from the presentation that we saw earlier, the estimate of between 75 and 180 euros per ton. The question that arises is what environment and what processes are possible that can use this expensive process in economically sound way. Obviously, one answer to that would be carbon price. Yes, probably if we have a carbon price of 100 euros and more, then carbon capture and storage will start making sense. But then you start wondering what are the processes that could survive at that level, that price. I mentioned earlier the case of the coal power generation. There is a big debate going now in Bulgaria. Is it possible to save probably the largest lignite complex in Southeast Europe, in Maritza East, through carbon capture and storage? But the fact is that the largest coal power plant there started losing massively money when the carbon price was around 20 euro per ton. So is it possible to develop something that will make a power plant that is losing massively money and almost coming to a bankrupt situation at 20 euros per ton with the technology that will cost 50, 60, 70 or 180? I think that is a very important question. And to conclude, I think we need very much an integrated approach. We saw it in some of the presentations, but we can't look at carbon capture and storage or carbon capture and utilization as a solution for everything. In the same way, we can't look at green hydrogen as a solution for everything, or solar energy as a solution, or wind energy, or energy efficiency. All these technologies have to work together, and they have to interact with each other. So we have to develop also our mindset and also the public perception, which is a major issue and major problem, especially when it comes to political decision, to think holistically and in a much more complex way than trying to find the solution. There is no many that have place in our common effort to reach carbon neutrality. And what we need in this combination is much more research, work on regulation, on cooperation and public debate. So there is a lot of work, and the horizon that was mentioned of 10 and 20 years when things will probably in the CCS and CCU landscape start to mature sounds to me quite realistic. So whether it will be 10, 12, 20 or somewhere in between, but we're looking for a set of solutions that is placed somewhere there in my personal view. So thank you very much. Incredibly fruitful and enriching debate.
Thank you, Julian. I think that was an excellent summary, and thanks for sharing your views. We have reached the end, but I'm going to, before we close, I'm going to extend for those who are still available for about 5 minutes. If there are any burning questions or comments you need to share, then now is the time to do that. Otherwise, Marko will follow up by email with his questions for those people who would like to comment further or answer them, so then we can include them in his report. So go ahead if you want to ask or comment on anything. We still have some time. Yes, Tomasz, please go ahead.
Yeah, thank you. I would just maybe like to comment on the, let's say, very interesting elaboration of Julian, and maybe on this debate whether we have really storage or usage or what is in between. I think in any case where we need to look on the solutions of storage or usage, we need to capture CO2 first. And this is, I think, clear. And therefore, I think we should focus maybe in these first steps that we need to do on developing these capturing technologies. And on the way of development, we will learn more and we will maybe see some opportunities, and maybe we will see this CO2 at the end of the day more as a resource rather than a problem. And we can then develop these, let's say, new solutions further. For me, it would be a pity to be stacked in maybe searching for the final solution and not developing some tools that we anyhow need to develop. And therefore, here I see also let's say, a benefit of creating such, let's say, pilots or demonstration plans where we can really open the playground for development of these new technologies. Thank you.
Thanks, Tomasz. I'll just, if you allow me, just say that we should not wait with developing storage. As we can see from projects in Norway and the Netherlands, it takes 6 to 8 countries from the the first feasibility study to the planned completion of CCS, and we're talking about countries who are experienced in oil and gas exploitation. So would be, I guess, good to develop capture, but also not to wait with developing storage. Any other comments or questions from the audience? If not, I'm going to thank again all our speakers. Thank you for the work you put into preparing your presentations and for sharing that with us. We are going to use this meeting and what we've discussed to finalize the report that is prepared by Marko. And later this year, there is going to be a regional event around the CCS4CEE project. So please stay tuned. You will hear from us, and I hope to see you again at our future CCS events. Marko, do you have anything else you want to add before we close?
I think you've summarized. I just wanted to thank all the participants. I think it was very insightful discussions. As mentioned, I'll follow up with some additional questions to include in the report. And I think as long as we keep these discussions going in Slovenia as well, I think we can certainly kind of start things up and hopefully develop a pilot project by 2025, as was suggested by number of individuals as being a goal. So I will certainly be doing my part on keeping CCS and CCUS on the agenda in Slovenia as well. So I'm looking forward to where this project takes us in the region as well. So that's about it from mine. Thank you.
Thanks, Marko. So I'm gonna wish everyone a great summer break. Maybe for Slovenia, that's not so much the case with the upcoming Slovenian presidency. I hope it's going to be a successful one. But for those who are not involved in managing the EU for the next 6 months, I hope you will have great holidays. Thank you. See you.
Thank you. Bye-bye.
Bye.
Thank you.
Bye. Bye.